Hello, everyone. Good afternoon. Dear authors and invited guests, welcome to the technical session 5B. Myself, Aarti Mohan, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you to the 8th International Conference on Smart Trends in Computing and Communication SMARTCOM 2024, Pune, India. The 8th edition of the conference is being organized in a hybrid mode. The physical event is organized today in Pune, India, and the virtual event is being held through Zoom today, that is 13 January 2024. I hope you will enjoy the knowledgeable and interactive session through the day. In this session, we have 10 presentations. Each presenter will be given 8 minutes for the presentation and 2 minutes for question and answer session round. On 7 minutes, I'll raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we get started, I would like to introduce you all to the session, to the chair for the session. We have two session chairs in this who would be chairing the session. One is Dr. Akhilesh Kumar Sharma and the other one, Dr. Chaya Jadhav. We welcome you, sir and ma'am.
Thank you.
Yeah, thank you.
Thank you.
Dr. Akhilesh Kumar Sharma is a professor and head, Department of Data Science and Engineering, Manipal University, Jaipur. A PhD, a DRC committee member. He is a ACM Student Chapter Faculty Representative, ACM Professional Chapter Joint Secretary, founder CIDCR, Cognitive Intelligence and Data Computing Research Lab Facility. His area of interest include machine learning, data science, data mining, MIR, clustering, classification, data analytics, big data. His area of expertise lies in data mining, classification, clustering, data analytics, MIR, big data, health data science. His area of research includes data mining, classification, clustering, data analytics, MIR, big data, healthcare data science. We welcome you, sir. It's a pleasure to have you on board for the conference.
Yeah, thank you.
Next, we have Dr. Chaya Jadhav. She's working as an associate professor at Dr. D.Y. Patil Institute of Technology, Pune, India. Having a total teaching experience of 26 years, she has more than 25 research papers published in international journal and conference. She has 4 copyright and 3 patents. She's working as a subject chairman at SPPU Pune and also a PhD guide at Pune University. Ma'am, it's a pleasure to have you on board for the conference.
Thank you.
Now, moving on with the presentations, I would like to invite Ashutosh Kumar to present his paper on a deep learning approach for evaluating children's handwriting. Sir, could you please proceed with your presentation?
Yeah, sure, ma'am. Am I audible?
Yes, sir, you are.
Yeah, let me share my screen, ma'am. Yeah. Hi, everyone. This is Asutosh Kumar. I am going to present my research paper, Deep Learning Approach for Evaluating Children's Handwriting. My co-authors are JB Seema and Srinivavi. I have done this research during my master's from Adyabha University, Bangalore. Moving ahead on agenda. So agenda is I will walk you through from introduction, to the conclusion and future scope. Introduction, if I introduce my problem, facilitating precise writing proficiency in early learners is crucial for their foundational development in writing and accelerating their cognitive abilities. While traditional handwriting instruction methods are valuable, they may not always provide the specific validation needed to ensure accuracy. With the advancement in NLP and computer vision, intelligent system can be built to evaluate and provide feedback on handwritten text. The significance of this topic lies in the evolving digital landscape and the increasing emphasis by governments on reducing paper usage. In light of these trends, there is a pressing need for a system that can effectively enhance children's handwriting skill in a digital context. Moving ahead on objectives. So our objectives were creating a deep learning model for online handwriting recognition tailored for early learners to improve their graphomotor gesture, give feedback based on character label, create a user-friendly interface for user to mimic displayed words. The model evaluates the input and provide feedback. Test the model and feedback system with a small user group to measure improvements in handwriting accuracy and overall writing ability. These are the some of the papers I have referred to build my concept. So these papers are most on recognizing the children's handwriting, but I have taken one step further to assist them to improve their handwriting. Uh, Moving on the project methodology. So first step was to handcrafted character generation. So for this, we had to solve this problem. Initially, we considered some of the public handwriting datasets such as EMNIST, IM dataset, but the trained model were not generalizing well on image written digitally on HTML canvas. So, and last we decided to create our own handwriting dataset more closer to how a second and a third standard kids used to write. It is worth to note that the constructed characters intentionally deviate from the usual children's writing style. The aim was to represent a basic to slightly artistic form with the goal of improving children's handwriting to a level recognizable by everyone. So the dataset was built by setting up an HTML canvas and sharing it with a small group of 10 members of different age group. Participants were asked to create all English alphabets in different fonts, producing 80 unique handwritten samples for each of the letters. To enhance diversity and reduce model overfitting, each sample underwent 5 different augmentation. So, and then we have done pre-processing such as min-max scaling, resizing, and then resolution adjustments and after the multiple iteration we have came up with the architecture with 3 CNN layer with ReLU and max pooling, and in inference we have done thoroughly inference and testing and created a web app and integrated with the model. Moving ahead with the model implementation, so this is the final model which looks like it has 3 convolutional layer with ReLU and max pooling. First layer has 32 layers, and second one has 64 layers, and third has 120 layers. And then there are flattened layer, fully connected layer, and output layer of 52 classes for 52 alphabets. Here is the dataset preview which we have created for ourselves, and if I talk about the result analysis, tested multiple combination of deep learning algorithms and picked the architecture which has outperformed among them. So we have tested with Sami's network, CNN plus LSTM, and CNN plus flatten layer. So the outperform model was CNN and plus flatten layers, which gave us 95% of accuracy. So we picked it for final evaluation. Performance analysis. We have tested on metric 4 type of metrics: accuracy, precision, recall, and F1 S4. All have given accuracy between 95 to 96%, which tells that the model was not biased to a particular class, and it was giving the preference for all classes equally. Moving ahead on the real-time model inference, so you can see we have given a drop down where a user can select a word to practice, and based on that, the graded canvas will be loaded based on the length of the given word, and it is able to flag out the wrong written alphabets. So it is validating on the character label. Moving ahead on conclusion and future scope, the model, I can conclude with the model constantly accurately recognizes characters across various handwriting style and fonts. Scanning needs more style and variance of data. Future scope is a diverse data set from 30 to 40 users is necessary to enhance recognition capabilities, strengthen accuracy, and increase resilience. Training of the model for cursive handwriting recognition is a significant step forward for handling diverse writing styles. Exploring multilingual character recognition opens opportunities for users to practice handwriting in various languages. These are the reference which I have taken to build my concept, and that's all. Thank you so much.
Thank you, sir. Thank you for your presentation. Ma'am, sir.
Sir, just I'm having nice presentation. So, are you considering cursive writing for this?
Uh, Not, ma'am. It is mentioned in future scope, so we are working on. Uh, as of now, it is not able to identify cursive handwriting, but yeah, we are in a stage where to create the cursive handwriting data set.
Okay. So, do you know the graphology like that? Graphology?
Graphology.
Huh?
Can you elaborate? I'm not aware.
Graphology, basically, it is a science for detecting the handwriting from the handwriting of that particular person. We predict that.
Hmm.
Huh? So, that is our motto for this.
No, ma'am. Detecting, like we are not focusing on identifying the users. We are only focusing on like training and giving an environment to where kids can practice again and again to improve their handwriting skill. Since they in beginning they have a graphomotor skill, a graphomotor gesture. To enhance that graphomotor gesture, we are more aligned towards that, ma'am.
Okay.
Yeah.
Okay. Thank you.
Yes, ma'am.
So next.
Yes, ma'am. Thank you so much.
Thank you, sir. Thank you, ma'am. Now, moving on to the next presentation, I would like to invite Sakshi Masurkar to present her paper on a survey on imparting education using augmented reality. Ma'am, could you please proceed with your presentation?
Yes, sure, ma'am. I have shared my screen. Is it visible?
Yes, yes, visible.
Yeah. So, good afternoon, esteemed audience. It is said that if you can't explain it simply, you don't understand it well enough. I, Sakshi Masurkar, on behalf of my team of authors, Rishu Jha and Professor Hemant Kumar Mari, am privileged to address you on our project's topic, imparting education using augmented reality. In the next few moments, we will unravel the potential of augmented reality as a sophisticated education tool reshaping traditional teaching methodologies. Augmented reality refers to a technology that superimposes computer generated information such as images, videos, or 3D models onto the real world. Moving towards the motivation for our topic, we are focusing on unlocking the boundless potential of education through augmented reality, transforming classrooms into immersive, dynamic environments where learning transcends traditional boundaries. With augmented reality, students embark on captivating journeys of discovery, fostering curiosity and engagement. We are embracing the future of education where each lesson becomes an unforgettable adventure, igniting a passion for knowledge that lasts a lifetime. In this slide, we have mentioned a few papers which we have referred for completing our survey paper. The common challenges that we have faced is that there is a lack of information in those papers, which we have tried to overcome in our survey paper. Objectives behind our projects are improve student engagement and understanding of electronic components through interactive and immersive AR based learning experiences. Secondly, foster inclusivity by accommodating diverse learning styles and abilities, making electronic education accessible to a broader audience. This is the working model of our project. We have pasted a snippet of it. So basically, we had a electrolytic capacitor for which we tried to build a 3D model. There are three virtual buttons on the image target. By clicking on each virtual button, you'll get more and more information about the capacitor. The first button is of capacitor overview, which tells us more about the electrolytic capacitor. The second button is of analysis, which will give some formulas related to electrolytic capacitor. And the third one is for the graph, which will show us the graphs for electrolytic capacitor or the concepts related to it. Yeah, so in the second snippet, the analysis button is showing the video where we have explained what are capacitors. Concluding with our topic, a survey has unveiled the transformative potential of augmented reality in education. From enhancing engagement to fostering real world application of knowledge, AR offers a dynamic approach to learning. As we navigate the future, let's embrace the opportunities AR presents, making education not just informative but experiential. Thank you.
Okay. Yeah. Sakshi, it was a nice presentation. I just
Yes, sir.
wanted to ask you how you have validated this entire thing. Any validation have you done?
Validating what I have validated
Have you received any results? Then have you got any validation of your results?
for the project.
Yeah.
Yes, sir.
So how you have validated that thing?
Validated in the sense of we have shown our project to Dharma, one of the professors in our college. She had validated it.
Okay. And
Yeah.
what was the validation criteria?
The validation criteria was basically, sir, she wanted to get the 3D models of any of the electronic components. So basically, as of now, we were targeting capacitors, heat sinks, and resistors. So we had shown her the 3D models for these three components. And the next criteria was the working of the virtual buttons.
Okay, fine. Thank you.
Yeah. Thank you, sir.
Okay. Thank you, Sakshi.
Thank you. Moving on to the next presentation. We have Sudhir Manivannan to present his paper on automated gym exercise form checker, deep learning based post estimation. Sir, I would like to call you for proceeding with the presentation.
Hello, am I audible?
Yes, sir, you're
All
audible.
right. Just give me a minute. Okay, am I sharing?
Yes, sir, the screen is visible.
All
Yes,
right.
it's visible.
Thank you. So hello everyone, I'm Sudhir Manivannan, and I'll be representing paper 128, automated gym exercise form checker, a deep learning based pose estimation. So the other authors who have contributed to this paper are Yuvan, Zain, Pooja, and our mentor, Dr. Bharati. So I'll just briefly take you through the contents. We'll first look at what the problem statement is and why we need an AI solution for this problem. Who is our target audience, and the exercise standing dumbbell shoulder press, how it is done, and the methodology we've taken. And then we'll talk about results, the threat to validity, and our future scope. Right. So what we have developed an AI tool which will analyze the gym users form if it's correct or incorrect. So the when the user is having an improper form, that may target unintended muscle groups. So that might not we might not be able to achieve expected gain in muscles, right? That's the result. Or it also could lead to serious injuries. So what we have developed is a real-time exercise form checker. So this would give a feedback if the form was correct or incorrect. So, okay, why do we need an AI solution? There are other options out there. Like hiring a personal trainer is the best option out there. but it is also the most expensive and inconvenient option. They charge around, I'm just giving gross approximate, like 5,000 a month. So that is very expensive for a lot of people, even for me as a student. And it is also very inconvenient because of the timings. Maybe they might be available in the evenings and I might not be able to use their services at that time. So there are also other products in the market which uses sensors and other hardwares. But the thing is, it's again inconvenient. Whereas there are other products which uses phones, but then the thing is, users may not be in the frame or may not be. So and that processing isn't very effective. So we use CCTV cameras instead of mobile phones. So it's very much more convenient for the users. The other option is to reference online resources such as YouTube videos or any websites. But the thing is, if it's an unreliable source, it might not be very helpful. So our target audiences, as I said before, are gym enthusiasts who can't afford to pay the gym trainers, who would like to work out in their own comfort of their homes. Even seasoned bodybuilders can use this to verify their form and other things. Okay, so we have used standing dumbbell shoulder press as our exercise. We've created data set on this exercise. So basically, we have 4 phases: a starting phase, press phase, lockout, and lowering. In the starting phase, the user stands upright with the dumbbells in their hands and then has a 90-degree at the elbow. So the press phase is them pushing the dumbbells up all the way, and when the elbows at 180-degree, that is the lockout phase. That's the third. And then we slowly bring it down. This is how standing dumbbell shoulder press is executed. So this exercise primarily focuses on the deltoid muscles, which is the pectoral and usually the muscles near the shoulder joint. So coming to methodology, the first thing which we did in our project is collecting our data and pre-processing them. So we looked online for synthetic data, and that wasn't very relevant because it was more of simulated from mobile phone cameras where we were dealing with CCTV footage. So we went with our own data set. We created our own data set. So I have pictures of some samples here on the right. The first picture being the sample correct form, and the second is incorrect. So we created 15 to 20-second long videos, each containing about maybe around 8 to 10 repetitions, I think, which is 2 to 3 seconds long. Each repetition is 2 to 3 seconds. Okay, so once we have the video, we have to detect the humans. So how are we doing that? We are doing that using a pre-trained YOLO V4 object detection model. So here is our another co-author, Zain, who's doing his exercise. And the YOLO model is detecting him and annotating him as a person. So what we would do is crop within the bounding box dimensions and send it to the next phase, so that we don't have to deal with any other noises in the background. Okay. In this phase, we extract key points from the human body, from the cropped image. So we've used TensorFlow light movement model here. And as you can see, we have extracted XY coordinates of each joint. Here we have taken the wrist joints, the elbow joint, the shoulder joints, the hip joints, knee, and ankle. So once this is received, we move on to the next phase. Okay, now once we have the joints, we will be able to create vectors with these two formulas. And once we have vectors, we can calculate angles with the third formula. So once we calculate the necessary angles, we'll be feeding it to a model, which we call automated form checker. So automated form checker is a multivariate LSTM. So each and every single frame has 4 angles. So a video would contain roughly about 300 frames. And in
Sir,
each frame, yes,
could you please conclude your research?
yes, I'm just concluding a bit. Sorry to waste your time. So each frame will have 4 angles, and we will be feeding them to the LSTM. And we have LSTM layers and dropout layers. And at the end, we will classify if the form was correct or incorrect. So this is our pipeline. So where we have an input image, which we detect the person, and then we calculate angles after we get the points. And we calculate only 4 angles: the shoulder and the elbow joints. So once we have these angles, we feed it to the multivariate LSTM, and we get our result if it was correct or incorrect. So coming to results, we achieved a 99% training accuracy and 98.88% accuracy. But the more significant thing is out of roughly 90 instances, we got only 1 instance wrong. So our threat to validity is, of course, though it is a very good tool, it can never replace a human trainer. And our application, though it says the form is correct or incorrect, we aren't providing them a feedback. So a future scope is that as of now, we're taking care of only 1 person, but later we will be trying to do with multiple people in public gyms. And we could take it to other sports, other exercises, and more. And we can also provide corrective feedbacks. Thank you.
Thank you. Just one question. Have you considered the age factor during
So,
preparation of your results?
sorry, I can't hear you.
Age factor.
Age factor of the gym user?
Yeah.
No, we're not considering the age factor. We're just considering about how the form is right. If the extension of the arms are correct, or the angles which are forming between the joints are correct, but there's no age factor.
Okay. Okay.
Is that all?
Okay. From my side, it's okay.
Yeah, fine. And did you receive any false positive? That is my question.
False positive. Let me come back to that slide. Yes, we received only 1 false positive, but no false negatives.
Do you think there is a bias in your data?
Bias in our data, well, we did collect a lot of data from multiple locations, various angles, and hence we had a 70-20-30 split. So though the numbers are high, I don't think there is a bias.
Okay, fine. Thank you.
Thank you, sir. Thank you for
Thank
your
you.
presentation. Thank you, ma'am. Thank you, sir. Moving on to the next presentation, we have Pushpalata MN to present her paper on emotion detection for the blind using deep learning. Ma'am, could you please proceed with your presentation?
Hello, am I audible?
Yes, sir, you are audible.
Yes, audible.
We are doing a project on emotion detection for the blind using deep learning. And the authors are Pushpalata, Evangeline, Rohan, Sneha, Suchinta, and myself, Vishnu. So we'll be starting. So basically, this is an emotion detection for the blind using deep learning project. And it's for the blind. So usually people with visual impairment struggle to navigate new environments and identify people due to their reliance on vision. Recognizing emotions, crucial for social cues, is especially challenging for them as they can't see facial expressions. Misunderstandings arise when voice tone and facial expressions don't match. A new technology using machine learning algorithms translate facial emotions into vibrations and audio, aiding emotion recognition for the visually impaired. This technology improves social interaction and understanding for people with visual impairments. So what is the purpose of this project? So this will enhance communication between the visually impaired and other people. This will reduce misunderstandings as the visually impaired is able to read the expressions and judge accordingly. Increased confidence and independence. improved emotional well-being, and accessibility and inclusion in the society. So the objectives of this project are design and develop a deep learning based model that can detect emotions accurately from facial expressions and other non-verbal cues. Build a user-friendly interface that can be easily used by blind individuals, allowing them to receive real-time feedback on the emotions around them. To provide haptic and audio output for the emotion detected. So these are the already existing models which we referred. So the first one is the Aswati Ashok's system. This approach leverages Haar cascade and deep learning algorithms for real-time face detection and emotion recognition from facial expressions. The other one is the blind assistance device using artificial intelligence. In this project, they combine facial expression detection with gender recognition and text-to-speech conversions. The yes logic facial expression recognition in this project, this project implements various deep learning models, including CNN. So these are the few papers we referred. So we have referred for a lot of papers. We have put 4 here for literature survey. So the first paper was published in the year 2020. It's a region attention network for pose and occlusion robust facial expression recognition. This study develops a region attention network or RAN to enhance facial expression recognition in challenging conditions like occlusion and pose variations. The other project was the deep facial expression recognition. The research paper provides an extensive survey on deep learning in facial expression recognition, detailing its evolution from classical methods to sophisticated deep learning models. The other two projects are facial expression recognition for the blind using deep learning by Ginu Lilly Joseph and facial expression and attributes recognition based on multitask learning. These papers respectively tell the first one, which was published in 2021, details developing a facial expression recognition system for the visually impaired using deep learning. It explores two CNN models, a custom CNN and a modified mobile net using transfer learning. The research in this paper develops lightweight neural network for multitask facial analysis, including emotion, age, gender, and ethnicity recognition.
Let us now talk about the proposed about our proposed system. Our first step is to extract faces from the video frame. Faces are initially detected in real-time frames using algorithms like LBP cascades. These are extracted using histogram-oriented gradients and facial landmarks. This is followed by the feature extraction step. Critical information like eye depressions near the eye and lip shape is extracted from the faces, providing a rich input for our analysis. Our classifier is trained with a data set consisting of 163,000 images from two data sets, namely FAR 2013 and MMA FEDB. The size of each image is 48 by 48, and they are clustered into emotions like happy, sad, and angry. We use various machine learning algorithms to learn the relationship between the corresponding features. Here is a detailed workflow. The first step in our workflow is the input, which is the video stream from the camera. This is broken into individual frames. This is followed by face detection. The LBP algorithm, which we have used, analyzes each frame to detect whether it recognizes a face or not. Once a face is detected, our MobileNet V2 transfer learning algorithm predicts the emotion associated to the corresponding face. This gives an output whether the face and emotion were detected, and a user feedback is also generated. So these are the results of our project. Since we have various categories of emotions and the usage of LBP algorithm, these are the results that were generated. As you can see, the precision values and the recall values and the accuracy values. Before switching to LBP algorithm, we started out with Haar cascade algorithm. The advantage with Haar cascade algorithm was that it was slightly more accurate, but the processing speeds were significantly lower. As you can see, the focus was to prioritize speed for swift emotion identification rather than higher accuracy. And thus we considered that LBP would be a better algorithm in our context. Here are the results we discovered when using Haar cascade and LBP. As we can see, the execution times of LBP algorithm are significantly faster when you compare it to the Haar cascade classifier. To conclude, our project attains an accuracy of 78% when evaluated on the validation dataset, which combines the MMA and FAR datasets. This is made possible through the application of transfer learning with the MobileNet V2 model. Most notably, the solution's adaptability is highlighted by its integration into Android applications through TF-Lite conversion. Our future scopes are expanding accessibility by launching it on the Play Store and the App Store, enhancing functionality by incorporating object detection capabilities, improve accuracy by optimizing the algorithm, and integrating the application with Google Assistant so that it becomes hands-free and easier to use. These are our references. Thank you.
Any two reasons why you using the Haar cascade transform?
Sir?
Can you state any two reasons why you are using this Haar cascade transform?
So
And
actually,
what-
we started out with Haar cascade, but then now we've switched to LBP, as LBP is much faster than Haar cascade algorithm.
Yeah, so any advantages you can list it out?
Advantages, sir, that the speed of LBP algorithm is approximately 4 times higher than that of Haar cascade. So we started the project with the Haar cascade model, and then we switched to LBP because LBP was much faster than Haar cascade.
Okay, and what about your this accuracy performance comparison?
Yes, sir. Our accuracy with LBP using LBP algorithm is 78%, and using Haar cascade is 79.6. So we've traded off speed for accuracy by switching to LBP.
There's not much difference, no?
Yes, sir. The accuracy, there's not much difference, but LBP, again, processing speed is much faster. So that's why we have stuck with LBP.
Okay.
Actually, the reason why we chose speed over accuracy is because we'll have to do it in real time. So every second we'll need to see the expressions change. So especially in this project, speed will be prioritized over accuracy. So even though the Haar cascade gave higher accuracy, still we chose the LBP because LBP was faster and the difference between accuracy wasn't much.
And during the this process of choosing the algorithms, did you find any other algorithm which can also works faster?
Hello, are we audible?
Yes,
Yeah.
yes, you're audible.
So we found other algorithms like the facial action FACS, and we could use other algorithms like the TBN. But we realized that these two algorithms were the most perfect and fitting algorithms for this model, considering we'll also need speed and accuracy. So hence we chose this model.
Okay,
But
great. Thank you. Yeah.
Thank you.
thank you.
Thank you, sir, for your presentation. Just a minute. Can I know the name of the other author who presented?
Ma'am, Vishnu and Rohan, ma'am.
Vishnu and Rohan. Okay, thank you. Moving on to the next presentation. We have Mahan Mitrar H to present his paper on Polysyntax, Political Sentiment Analyzer. Sir, could you please proceed with your presentation?
Am I audible?
Yes, yes.
Good afternoon to all present here. I myself is Mahan Mitra, and my co-author Rohit Kumar and my mentor is Dr. M. Babu, and we have done a paper on polysyntax, which is a political sentiment analyzer. So this is the agenda that I am going to get you through today. Okay, first, why social media for politics? So in this 21st century, social media shapes politics in a larger way. Nearly 60 to 70% of the local users in India are dependent on social media to decide who to vote on with the tweets and the posts that they are getting through. And it empowers politicians, public figures, and citizens to engage in a real-time discussion, influencing their public sentiment. As I said, these platforms like Facebook, Twitter, and Instagram, they serve as the influential tools for political discourse. So I had a question like, if this much of the influence is made by the social media into the politics, is it democratic and is it transparent? And that question moved us upon to make a project, Polysyntax, which is a web platform, in short, which is like a Wikipedia for politics, to let you know the information and the answers to why we are voting and who we are voting and the reason behind that. As I said, the motivation for this project is to make the things transparent and democratizing the political discourse. Though the hello, am I audible?
Yes, sir, you are audible.
Okay. Though the electoral things are being made in a democratic way, we thought the influence of the information into the social media post are actually misleading us, and we just wanted to make a way out of it to make this disclose that we just want to represent the information as it is. So the literature survey, as I said, the first quest that we got from it is, could we predict an election just using a Twitter or any social media? And the first paper, as we said, it was a paper written to just say how the prediction would be made with Twitters and the percentage with that. And next, we read upon the opinion mining and the sentiment analysis that we are about to do with these tweets and the other models, the BERT model and CNN, which are used for the opinion mining. And the main paper that we refer was the filter bubble. That is that is to study on how the post directly influence the people mindset. And this is the functional requirements that we are covering in our project. The first one would be the data collection, pre-processing, sentiment analysis, and data visualization. I'll be covering upon this in the later slides. And these are the non-functional requirements. So this is the basic architecture. If you take our project, is divided into two stages. One is pre and post election, and the other is the during election. During the pre and post election, we'll be having a web page that just collects data from the people and also from the social media post. And with that, we will be correlating the trending topics as of now in a particular place or particular location. And with that, we'll be collecting the public views and the opinions, and we'll be converting them into a graphical representation. As it is stated here, the user engagement and contribution tool will be collecting the views from the people, and also from the new from well estimated news articles, and also from social media will be collecting and storing into a databases, and that will be processed, and then with like referring from tokens will be separating it as a positive tweet or a negative tweet or a supporting and a disapproving tweet, and we'll be letting the people to have a chat upon that or share their opinions on that. And by taking all these opinions together, we'll be converting that into a visual representation. As I said, the data collection, it aggregates data from diverse sources like social media, news outlets, and user contributions, offering instant insights into the ever-shifting public sentiment on the political topics. The data processing, as I said, will be separating the entire tweets and the post into smaller tokens, and that will be connected into extreme sentiments like a positive tweet, a happy tweet, or a sad tweet. And with that, that would be processed
into making it into a visual representation. As I said, they're training the data. Initially, we are going to get the data from by using the social media APIs, like for Twitter and Instagram. Initially, we are starting it out only concentrating on Twitter and manual tweets. Visual data representation, we are going to like every topic that is being stated in our web page, each topic will be having a visual representation saying like how much percentage of the people are supporting this issue or opposing this issue. And if you click on that, it will be letting you into getting the reason why people support it or against it. And it also show you with the proof of the news articles stating what is the issue all about. Like I said, the more and the more the user contributes, the more and the more accurate and the more diverse the opinions will be gathered. So for that, we have let chatbots that will be talking upon with the users to get their opinions and add it to the opinion mining. And we also focus on the privacy and data security, as there it is one's own interest on letting out their name and stating the opinion, or they could be anonymous and share their views and opinions on a particular political topic. Conclusion, as I said, the entire idea is to check on the efficiency of how much a social media post could determine an election result or how it could affect the election result. As I said, the web page is divided into two parts: pre and post election and during election. And this pre and post election tweets, opinions, and everything will be gathered and could be used to determine the election result before the actual election happens. And as I said, from a literature survey that I showed, nearly like 65 to 70% of the result could be accurately judged with the social media posts. And we are empowering this democratic participation. It is not just a platform. We are trying it to make it into active democratic participation by letting people know the reason behind the voting and why they need to vote a particular leader. Future work, as I said, it is entirely based on the posts and tweets. So we have to make it a point that a post or a news is a fake news or a true news. As if I'm making an entire opinion mining just considering a fake or a spam tweet, then it is of no use. So we are focusing on it to identify the accountability and the trustability factor of the news. And also multilingual expansion will allow multiple region people and local tweeters and local peoples to share their opinions and add that to our project. Thank you.
Thank you. Is it this work is sponsored?
No, ma'am. As of now, we are trying to showcasing it to our college chairmen and principal. We are currently doing the project. So if we are getting a particular result, then we'll be asking them for a expansion of the project.
Okay. Yes, sir. Akhilesh, sir.
Yeah, no problem. It's okay. Fine for my side.
Okay.
Thank you, sir, for your presentation. Thank you, ma'am. Moving on to the next presentation, we have Nitika Goyal to present her paper on predicting the air quality using machine learning algorithms, a comparative study. Ma'am, could you please proceed with your presentation?
Yes, sure, ma'am. I'm sharing the screen.
Yeah.
Ma'am, is my screen visible?
Yes, yes.
Ma'am, may I start?
Yes, yes.
Okay, thank you, ma'am. Good afternoon, distinguished guests, respected organizers, and my fellow researchers. I'm Nitika Goyal, an undergraduate research scholar at IGDTUW, and I'm truly honored to be presenting at SMARTCOM conference from virtual podium. Today, I'm excited to share insights from my research paper titled Predicting the Air Quality Using Machine Learning Algorithms, a Comparative Study. Before delving into the details, I want to acknowledge the collaborative efforts of my co-authors, Ms. Ritika Kumari, Assistant Professor at IGTTUW, and Ms. Poonam Bansal, Head of Department at IGTTUW. In this presentation, I will take you all on a journey through introduction, objective of the paper, research gaps, work description, machine learning models, work outcome, conclusion, future scope, and references. Introduction. Air pollution is a growing environmental concern with significant implications for public health and urban planning. Poor air quality can lead to a wide range of health problems, including respiratory diseases, cardiovascular issues, and even premature death. It also affects the quality of life in urban areas and can lead to economic losses. To address these challenges, accurate air quality prediction is very necessary. Machine learning algorithms have emerged as powerful tools for the purpose, offering the potential to provide timely and reliable air quality forecasts. The primary goal of this research project is to develop and evaluate machine learning models that can predict air quality parameters. By employing various machine learning algorithms such as decision trees, random forest, k-nearest neighbor, support vector machine, and naive Bayes, this research aims to enhance our understanding of air quality dynamics and improve the accuracy of air quality forecasts. Objective of the paper. The primary objective is to conduct a comprehensive comparative study of machine learning algorithms for air quality prediction to identify the most accurate and efficient models. The paper will outline the data sources and pre-processing steps, feature selection, and model evaluation techniques used in the comparative study. The paper will employ various performance metrics such as accuracy, precision, F1 score, and recall to assess the model's accuracy. The research aims to provide practical insights that can assist in air quality management, health policy, and environmental conservation efforts. Research gaps. Comparative studies gap. The research gap lies in the absence of a comprehensive comparative analysis of machine learning algorithms, which is crucial to identify the most effective methods for air quality prediction. Model selection challenge. Many studies have explored individual machine learning models, but there's a need to compare and evaluate a range of algorithms to determine the most suitable for different air quality parameters. Practical implications gap. The research also addresses the need for practical insights that can guide policymaking, public health responses, and environmental interventions based on accurate air quality predictions. Work description. We started with data collection. The project begins with the collection of data sets of air quality levels of various places given their air quality index. Two datasets were selected, that is Global Air Pollution Dataset and AQI Air Quality Index dataset obtained from Kaggle repository. Data pre-processing. The collected data was then pre-processed to clean, transform, and prepare it for machine learning. Steps include handling missing values, outlier detection, and feature engineering. Feature selection is also performed to identify the most relevant variables for prediction. Then we splitted the data into training and testing datasets. The training dataset was 70%, and the remainder was reserved for evaluating their performance. Model training. Each machine learning model is trained on the training dataset. Hyperparameter tuning may be performed to optimize model performance. Model evaluation. The trained models were then evaluated using the testing dataset. The following performance metrics were used. Accuracy, the ratio of correctly predicted instances to the total instances. Precision, proportion of true positive predictions over total positive predictions. Recall, the proportion of true positive predictions over the total actual positive instances. And F1 score, which is the harmonic mean of precision and recall. Machine learning algorithms we used were decision trees. They were employed for their ability to handle non-linear data and easily interpretable nature. They allow for the understanding of decision-making process. Random forest, it is chosen for its robustness and capability to handle a wide range of data types. Ensemble methods like random forest improve prediction accuracy. KNN is utilized for its simplicity and the ability to make predictions based on similarity to neighboring data points. Different values of K were also being used for optimization. SVM, it is applied for effectiveness in handling both linear and non-linear data by finding the optimal hyperplane that best separates data points. Naive Bayes, it is employed for its probabilistic approach to classification, particularly in scenarios where features are assumed to be conditionally independent. Work outcome. The results of dataset 1, that is AQI air quality dataset, are given as in the graph. And from this, we can infer that random forest classifier is performing exceptionally well with 99.9% accuracy as compared to other classifiers. Also, on the other hand, we can see that relatively least performing model is k-nearest neighbor with the accuracy of 98.8%. The results of second dataset, that is global air pollution dataset, are as follows. From this also we can infer that random forest classifier is again performing exceptionally well with 100% accuracy, while KNN has been the least performing model with 98.9% accuracy. Conclusion. In this comprehensive study, we delve into the realm of air quality prediction by implementing 5 well-established machine learning approaches: decision trees, random forest, KNN, SVM, and naive Bayes. These algorithms, known for their versatility and wide applicability, are put to the test in forecasting air quality using two distinct datasets sourced from Kaggle repository, the Global Air Pollution Dataset and the AQI Air Quality Index. Our evaluation of these ML models is based on a rigorous analysis using 4 essential performance metrics: accuracy, precision, F1 score, and recall. These metrics provide a holistic view of each model's ability to make accurate air quality predictions, thereby shedding light on their respective strengths and weaknesses. The findings of our research shed valuable insights into the effectiveness of these ML approaches. Notably, the random forest algorithm emerges as a standout performer, showcasing its proficiency in forecasting air quality across both datasets. Its remarkable accuracy and robustness make it a prime candidate for further exploration and real-world applications in air quality prediction. Conversely, the KNN classifier ranks as the least performing model in both datasets. This valuable insight highlights the areas where this algorithm may require enhancements or where alternative approaches may be more suitable. Future scope. Looking ahead, our future work will focus on expanding the scope of our research. This will entail the inclusion of additional datasets to validate the performance of these models under various environmental conditions and geographical locations. Moreover, we plan to implement and assess the performance of various other ML algorithms to further enhance the breadth and depth of our research. Yes, sir.
Nitika, yeah, that was a very nice presentation. I have one question, this concern. You're
Yes, sir.
belonging to Delhi, right?
Yes, sir.
Delhi is nowadays facing a lot of problems, challenges due to that air quality related parameters and the things. What is your research will be contributing and how it will be contributing and what is the solution? You are looking for the solutions. Just getting all these complicated algorithmic, these results will not help actually. The live data quality indexing prediction, what is the solution of doing these things? That is actually these things will help a lot in the society. And we expect you young entrepreneurs and the young scientists to pursue your research in that category will be a very good and fruitful. So what is your opinion in that? Can you discuss?
Yes, sir. In this research work, I mainly focused on the comparative analysis of various machine learning algorithms. But in future work, I'll incorporate what suggestions or what measures we can take to improve the air quality with the given work, like what we have done, like comparing machine learning algorithms. In the future work, I'll incorporate those. But this was the first research paper I wrote, so I mainly considered comparative analysis of various machine learning algorithms to help the government to know which machine learning algorithm would be more suitable for air quality prediction.
Yeah, we appreciate that work. And we also look forward to hearing from you in the real-time solutions of this problem.
Yes, sure, sir. Thank you for your suggestion. I'll incorporate this in my future work for sure.
Yeah, definitely.
Thank
Yes,
you.
same here, sir. What Akhilesh sir has given. So again, it should be in a practical application. So what
Yes.
what you are doing the research, again, it should be used or in a practical way. Again, how again your society will again help. Again, it will be done to the society. Just that should be your motto behind your research work. So it will be a very good work.
Okay. Yes, ma'am. Sure. My future work will focus on uncovering novel insights and solutions for more accurate predictions that can help the real-time scenarios.
Yes. Thank you. Thank you.
Thank you so much, ma'am, for your presentation. Thank you, ma'am. Thank you, sir. Moving on to the next presentation, we have Gabriela Mogus to present her paper on quantum image processing using edge detection based on robots cross operators. Ma'am, could you please proceed with your presentation?
Yeah, I will try, but okay. So let me share with you my screen and I will start my presentation. Okay. Can you see my screen? Can you?
Yes,
Okay,
ma'am,
it's
it's
okay.
Yes.
Okay, thank you very much. Hello, everyone. Good afternoon, in fact. My presentation today is related with a very hot topic, quantum image processing, and most precisely is how we can use the Roberts cross operators in order to detect edges in our quantum images. Okay, I'm coming from School of Advanced Technology from Xianjiang Liverpool University of China. Okay, I structured my presentation in 4 parts. The first one will be a very, very light introduction in the topic. Then I will show you how I was able to, so how can we store a classical image in to a quantum states, that mean to get a quantum image in this case, and then how we can identify, we can detect the changes or discontinuities of intensity in a quantum image we got previously, which is will be under edge detection, and the last but not the least, the conclusions. Okay, let's start with the beginning. From the image, the classical image processing, we know very well that there are some operators able to help us to detect the changes, the discontinuities in our images. The Roberts operators are the ones I've used in this proposal in my paper, but this time I adapted the old method based on the Roberts operators to a quantum image, and the flow, the way how I changed the things, that the steps I've used it are like this. First of all, I started from the grayscale image, a classical one, of course, and I converted it, which means I store it in a quantum states. In this moment becomes this old image, the classical image becomes a quantum image. So I did the first step, the quantum image representation, then applying the Roberts cross operators and the other ones, I was able to get to identify the changes and discontinuities on the intensity of my new quantum image I presented before. Okay, let's see the first step. First of all, I've started from a classical grayscale image, which was named, now we know it, everywhere we can find this image, is for free on the internet. I've used this, but not all of it, a part of it, a very small one, because of my resources. I couldn't do all the image I wanted, but for the sample, I've chosen the things for the sample. I've did it in this way. Yeah, let me move this because I have to show you all. First of all, I use MATLAB in order to get the matrix of the image, the matrix of pixels, and then I had to identify under 8-bit information contained by each pixel. I did it, and I get the same using the MATLAB we know, all of us. First of all, this is the sample I have used it from my image, and converting each pixel into 8-bit, make it in 8-bit representation. We have here the position of each bit on X, on Y, and then the 8-bit information within a pixel, each pixel, of course. Okay, this is the basic information I got and the start. I started. So this was the starting point in my quantum image representation. Okay, the first step was to implement quantum circuit and to simulate in order to get the quantum image representation of the previous of that small grayscale sample. First of all, I have to say, all the quantum circuit was implemented on IBM Quantum Experience platform, which is a cloud platform available for everyone. And the second implementation was done locally on a quantum QASM simulator on my computer, of course. How to store the sample image? Before, I've used 12 qubits. I've used, first of all, 2 qubits for each of the dimension for X and Y, and then I have used 8 qubits in order to get the 8-bit representation within a pixel. Okay, then, okay, let me move it. The circuit, it's not quite a complex one, but contains Hadamard, the quantum gates, of course. This is a normal quantum circuit. So I have used Hadamard gates in order to create a superposition of all the states and to get at the end the representation of each of the positions of each pixel into in this sample image, and also in order to manipulate each qubit. Yeah.
Could you please conclude your research?
Really?
Yes,
Okay.
ma'am. We have 8 minutes. Yep.
Oh, okay. So I've used an adapted model in order to create this storage. I stored the image and I got such as result. The next step was to use the edge detection. The edge detection on the under Roberts operators are based on 2 metrics. I've used the matrix in order to touch all the qubits of the image. I've used it a zero padding method, and then I've applying the Roberts operators. I was able to modify the vectors. At the end, I got some changes on the image, and at the end, the last step in my edge detection was to use a quantum CNOT gate, which is to apply some specific gates on each qubit in order to highlight such as edges, and of course to get at the end to get the changes I wanted on my picture. The conclusions, why I've used the Roberts, because the operators are very fast and we can use them very, very easy. Also, why I prefer to change the classical image into quantum one, because the speed, because the many other benefits quantum computing has, of course, and there are many other issues when it's the Roberts operators, but this will be the future work related to the noises in the pictures. Okay, this was my presentation.
Thank you, ma'am.
Yeah,
for the nice presentation. Thank you.
Yeah, it was a great presentation, Gabriela. I congratulate you.
Thank you. There are questions?
Only one question: why you selected
Please.
that Robert, this operator?
Yeah, sure. Roberts. Yeah. Operators. So there are two acting on X and Y on two dimensions, on the two dimensions. Yeah. Yeah. Please.
Okay. Okay, thank you. Yeah.
You are welcome.
Thank you so much, ma'am, for your presentation. Thank you.
You're welcome.
Moving to the next presentation, we have A3C to present her paper on routing strategies for quality of service optimization over vehicular ad hoc networks, a review. Ma'am, could you please proceed with your presentation?
Yeah, sure. Am I audible, ma'am?
Yes, ma'am, you are audible.
Yes, yes, you're audible.
Is it visible, ma'am?
Yes, ma'am, it's visible. You may please proceed.
Yeah, thank you. So today I'm going to present, good afternoon, everybody. Today I'm going to present the paper on routing strategies for quality of service optimization over vehicular ad hoc networks. It's a review. So along with the co-authors, Bharti ma'am, Rajesh, and Manjunath sir. Yeah, so the evolution in the field of telecommunication networking or Internet of Things and mobile communication technologies has resulted in various real-time applications in which smart cities are usually equipped with intelligent transport system. The main the problem with the cities is with the traffic. They need to deal with the traffic. So for that purpose, so that's why intelligent traffic system or the transport system, they're trying to use a VANETs. So VANET that exhibits the three major qualities. They try to do with the mobility of nodes at a high rate, the dynamic change of network and topology, and fragmentation of communication links and the network. So we have mainly focused on comparing various strategies of quality of service based routing in the case of VANETs. So strategies, we can consider anything. We also have look after on different mobility models and mobility methods that can be used to test the VANETs. And we also list out some of the research challenges in the area of VANETs, which still require considerable efforts for their improvement. I think on the slide, so we have just given how the VANET and the MANET. So we have just given a scenario of how the VANET works. So how it communicates, how there is a communication between the nodes with the RSUs and how they are trying to communicate with and how it will be helpful. So the advancement of the computing system and evolution of wireless communication technology has resulted the development of MANETs that allows message passing or message dissemination in between the nodes with or without fixed infrastructure. The MANET nodes are capable of making routing decisions that also helps in the multi-hop communications. Okay, so but the main difference between the MANET and the VANET is the VANET is a subclass of the MANET where various wireless products can be used in the car or any of the transport system that you're using. Like it may be a laptop, mobile phone, personal digital assistants, or remote keyless entry. There are various applications of the VANET that we can go through. One is the safety and the one is non-safety. Non-safety applications are like rescue system, privacy, and security, whereas non-safety are like automatic payment of toll-free. In the car, you can pay the toll-free, managing flow of a road traffic, advanced navigation services, or finding the closest of that. So VANET architectures that we have gone through is there are totally three types. The basically at the bottom we can see the VANET architecture. The other two is we have VANET architectures V2V, that is node to node architecture, and the one is between the VANET towards the infrastructure. We have two or three types of the architectures that we have gone through. So the first architecture that we're trying to talk about is between the nodes, we have a communication between the both, and we try to do it. Whereas with the routing nodes that exchange the messages through vehicle to vehicle in the case of the first, In the case of the second, they try to communicate between the vehicle to the infrastructure. Okay, and the one is the hybrid one. So where we have a combination of both VANET to VANET, that is V2V and V2I. You have a combination of both. So we have a bit of comparisons that we can go through between the MANET and the VANET. So we can have a parameters of density of nodes, approach of addressing pattern of nodes, mobility and all. So next we have a communication protocol in the VANET. So there are totally three types of communication protocols in the VANET. One is unicast, where we have a communication between the source to the destination node. A destination can be in a single location or it can be on a remote location. So whereas in the case of a multicast, we try to send the messages from thing to a group of destination nodes that are in the same geographical area. Where the broadcasters, we try to send source node, send the messages from source node to the data to all the neighboring nodes at once. So there is a transfer of broadcasting of the messages between the nodes. So there are various limitations that we have gone through in the case of a VANET, like additional control messages that by certain protocols for estimating that no effective techniques are adopted to calculate QoS parameters, or existing routing algorithms are not incorporate with the case of scalability and adaptability. Many proposed protocols lack of stability in the network in spite of increased complexity. So based on, that's why we have undergone with the study of this, what are the parameters that we can consider in the routing in the VANET. So I also reviewed regarding the realistic mobility for the VANET simulation. So there are three types of mobility models. One is mobility model on random mobility, and the one is on geographic map, and the one is the mobility map models on the group. So you can see in the slide, there are two diagrams. So the mobility models based on the random mobility can be classified into two types. One is a random waypoint and the one is random walk. In the figure, you can see the red circle, which indicates the current position of the vehicle, whereas all the green dots that you can see all over, it is the probable position that a vehicle can take based on the decisions that they have. So in the case of mobility models based on the random mobility, the movement of the vehicle, that is vehicle position, velocity and acceleration, adjust randomly. So they are trying to adjust it randomly. So whereas in the case of a random walkway type, so everything is represented, the VANET area is represented in the form of grid cells with the equal probability. Next one, we have a mobility models based on the geographic map. First is, in the case of a geographic map, any hidden obstacles or anything are also taken into consideration. Whereas in the case of the previous one, the mobility models based on the random thing, so they don't consider the obstacles or any hills or anything. But in this case, they are trying to consider that the obstacle hidden landscape and mandulating rural terrains and all. So based on that, they are trying to classify into three types: Manhattan grid. So usually in the urban areas, they are trying to use these type of model, that is Manhattan grid. So urban areas. So usually, the vehicles are usually moved in a crisscross direction at 90 degree in the rectangular fashion. Each road is of two lanes, allowing to and fro movements. The vehicle on reaching on some intersection has half of the probability of continuing in the same direction, quarter of the probability to go either left or right direction. The vehicle of the speed mainly depends upon its own speed on the previous lot, or the vehicle speed which is on the same lane. So both they are trying to consider for the speed of the vehicle. The next one is a city section, where they are mainly going to consider based on road topology. Yeah.
Could you please conclude your research?
Yes, fine. So based on the dissimilar roads or expressways or something, so usually the vehicles are trying to move in the same direction or in the perpendicular direction. In the case of city way, freeway is any way they can go. So with any of the thing, the vehicle can move. So mobility models, you have two types: reference point group mobility model and virtual track, and mobility models based on prediction, mobility models based on the software tools. These are some of the models that we surveyed. Open issues in the VANET is scalability, computational complexity, robustness, and self-organization. Finally, I'm going to conclude. So usually we have a famous quote that life is a journey, not a destination, but one should end life in a journey, however, should reach a destination. So surveys say 60% of the road accidents in a 0.5 seconds is going to occur, or 90% of the road accidents may occur in 1.5 seconds. So finally, we are going to conclude that most of the VANET they are trying to speak about is the projects they have undergone in various organizations and the researchers. There, in our paper, we mainly concentrate on the QoS parameter. The future work we can do is on the message dissemination in a VANET. It's usually risky that we can undergo with these VANETs. Thank you so much. These are some of my references. Thank you.
Yeah, Maitri, very good presentation.
Thank you, sir.
Just have one concern, like when in the VANET, all the vehicles are moving, one particular node is sending the message to the other, and if they re-send the messages, maybe the broadcast situation will occur. Will it be a problem in your congestion in your network, or it's not a case?
It's not an issue, sir. So because depending upon the area or depending upon whether we have an obstacle or not, or whether we have all that, depending on that, we are trying to choose the model and we are trying to that. So particularly for urban areas, we have one model. We have any other things, we have another model. So there is no issue, sir, for that.
Okay, fine. Thank you.
Thank you.
Thank you, ma'am.
Thank you, ma'am, for your presentation. Moving on to the next presentation. We have Priti Shahane to present her paper on Smart Rover for farm pesticide spraying. Ma'am, could you please proceed with your presentation?
Yes, ma'am. So Iksha will present on behalf of. Hello.
Yes, ma'am.
Yes,
Yeah.
sir.
So Iksha today is there. So our final year students, they will present on behalf.
Okay, ma'am. Iksha Dubey, right?
Yeah, yeah.
Okay. Okay, ma'am.
Am I audible, ma'am?
Yes, ma'am, you are
Yes,
audible.
yes.
Yes, you are audible.
Yeah. Okay. I would like to start by saying that we are having this project called Smart Rover for farm pesticide spraying. And our team members are Ashutosh Srivastav, Bilal Attar Ahmed, I am Iksha Dubey, and Pinaki. And our mentor is Preeti Shane, ma'am. Next slide, please. This is the scope of the this slides. Next slide. Starting with the scope of this project, we should know that the what is the requirement of the farmers. So before automating this spraying system, farmers usually had to do this manually, and this would expose them to many of the diseases. And because of this cause, we have tried to automate this farm pesticide spraying robot. These are the objectives of a smart rover, that we are going to make a height adjustable smart spraying rover, and we are going to integrate multiple technologies in it, and Pinaki will continue from this.
So my screen is still visible, right?
Yes, it's visible.
Yeah. So in this project, what we have done is we did an extensive review of what technologies were available in the industry and what impact we could create by introducing our own project. And in this, we mainly concluded with 3 points. One was precision of the spraying action. Second will be the reduction of risks involved due to pesticides. And with the precision, we also achieve a sub part of it, that is the protection of the environment, by using as much pesticide as required and not overdoing it. Coming to the block diagram, our system had 2 different setups controlled by 2 different microcontrollers. One was used to drive the rover in the farm, and the second was used to spray the pesticide as per the height of the crop. Taking forward, what was our methodology? We used a base structure of aluminium, used geared DC motors for the control of the rover. As I said, we had 2 microcontrollers. We used the basic Arduino Uno. For communication with the Arduino boards, we used a Bluetooth module. Then, once we have motors involved, we obviously had to use motor drivers, and these motor drivers were L298N and TB6600. The spring system was taken was introduced with the help of pump motor and a custom designed nozzle. This is the main highlight of our system. As you can see, I have labeled 1, 2, 3, 4. 1 is our ultrasonic sensor. 2 is the nozzle. 3 is a 3D printed link which is used for height adjustment, and 4 is a PVC pipe which gives the support to this link. This image shown is the top view of the design. Moving forward, this is our actual model, how it looks. As you can see in image 1 and 3, the link along with the lead screw and the stepper motor can go up and down, and the ultrasonic sensors right in the corners, either corner, is used to determine the height of the crop. The image in the center is the top view of our model, how it exactly looks. Moving ahead, this is the link that we have designed completely from scratch, and how it is used, how it was ideated, and how we have brought it into life. Moving forward, these are the costings of a project. It was a completely self-funded project, and we have been, you know, doing so much of research on it that it took us a lot of time to find the most optimum solution so that whenever it reaches the market, it could be launched at a very good price. These are a few of the references from where we have done our research on literature review and existing technologies and what technologies could be used and not. And that is all from our side. Thank you.
Okay, whether that model is approved and have you really used that model?
Ma'am, we are currently in the state of filing a patent for the model. So,
Okay.
in the farm, as in we haven't gone to any commercial or corporate farm. We have a backyard in our college, which is no less than a farm, means it has proper soil and has crops, as in not crops, but few plants. So we have tested it there and it is doing its job really well.
Okay, what is the approximate cost of this product?
Approximately, ma'am, if you want to launch it commercially, we should be able to launch it around 13 to 14,000.
Okay, 13 to 14.
Yes, ma'am.
Okay, thank you.
Thank you, ma'am.
Thank you for your presentation. May I know who all presented this, the name of both the presenters?
Ma'am, Iksha Dubey and Pinaki Katotia.
Okay, thank you.
Thank you, ma'am.
Moving on to the next presentation. We have Preeti Shane to present her paper on STM32 based home automation and energy monitoring system with TFT display. Ma'am, could you please proceed with this presentation?
Yeah, Sujay Shinde will present this. Yeah, Sujay, are you there?
Yes, ma'am, I'm there.
Yeah.
Good afternoon, everyone. And this is our final year project regarding STM32 based home automation system and energy monitoring system with a TFT display. The authors are Naval Shesagar, myself, Sujay Shinde, Shivam Srivastava, Akul Rajivan, Preeti Sahane, Sridhar Tudam, and Hari Krishnan R. So this is the agenda for today. Let me begin with the problem statement, and we'll go further with the block diagram methodology and the further things. So what is identifying the problem over here is that there are conventional energy monitoring systems which lack real-time and detailed insights into the individual power consumption of a particular appliance, and that makes it challenging to have a proper energy saving plan for us. So what we decide is to what we aim from this project is to make such a system that will help us track real-time data and give us detailed insights about the same. And additionally, we are also providing the option to control the on and off state of the appliance through the TFT display. And all of this is being controlled using the STM32 controller. So this is the block diagram of the project, wherein the load that is at the appliance, relay and energy measurement circuit will be connected to each other. All of that data will be processed by the STM32 controller, and through the TFT display, again, it will be connected to the STM controller, which will be controlling the appliance. The on and off state of the appliance can be controlled from the TFT display. So this is the methodology of the project, that the STM controller is the heart of the system and all the components are integrated through it. So we have used the ADE7757 energy measurement IC, which continuously monitors the power consumption, and it works by sending pulses as the output. So if 100 pulses are registered, that means 1 unit of energy is consumed. So using the AD7757 IC, we can do a single phase measurements, which is limited to household currently. And the TFT display, which is linked to the microcontroller, it will serve as the user interface. So it will display all the data and graphs for the power consumption. So this is the schematic of the energy meter circuit, which was designed using KiCad. We can see various components used here of the energy measurement. This is the GUI which we have designed on the TFT display, which was integrated to the STM microcontroller, and that was done using Touch GFX tool. So it displays a start button over there. And this is the actual implementation of the energy meter circuit, which we have done on a universal PCB circuit. And this circuit is made up of several components and each have a specific function. Resistors are used for voltage division and current measurement, and capacitors have been used for noise filtering, power supply stability, and diodes for polarity and over voltage protection. And we have also used the transistor for LED indication, and finally the trim pot for the fine tuning and current measurement gain. So all these components work together and ensure the ADE7757 does work properly and give us accurate readings. So to control the connected load, we have used 5-volt relays in the home automation setup, as we can see in the figure below. This is the next screen after the start, which we saw from the GUI. It has two options. One is statistics and the other one is control. So once you press on the control button, whichever appliance is connected to the power supply, the state on and off state can be controlled through that. And statistics will show the power consumption data to us. So this is the demonstration that we did, wherein we used a normal household bulb and the STM controller is kept below, and the graph has been generated for the power consumption of that. So talking about cost and scalability. So all the components which we discussed were the AD7757 IC, optocoupler, voltage regulator, capacitors, the BC547 transistor, diodes, and all of that, the STM32 with the integrated TFT screen. So estimated cost for this project, to demonstrate this project, was around 5,000 rupees. And in terms of scalability, right now, we are only serving for domestic purpose because single phase power supply measurement is possible through this IC. If we want to look further for industrial measurement, that is the 3-phase power management, then we have to use the AD7758 IC, which is better suited towards that. It has better capabilities for polyphase energy management. So the novelty of this project is we can have individual appliance monitoring, which will give us the real-time data for each appliance, and we can see which devices are consuming how much energy at any given point. So one we have is the interactive TFT display, which we are giving as an additional feature, which will offer you the control on and off states of the devices. Then we have accurate power measurement. Historical analysis, it can be done, which we can add a feature, we can have a memory. So all the data, the consumption data of the energy can be stored, and then later we can use algorithms to further analyze the uh, consumption patterns of the particular appliance. And future expansion, it allows us for integration with smart home platforms. This is the future scope, which we already discussed in the previous slide. Energy optimization algorithms we can develop, and to suggest a proper usage patterns. We can also add voice and gesture control, and also we can have remote operability, so that we can use the data and everything through mobile applications and a remote controller. So we conclude by trying to propose a solution for the proper energy management and energy saving. And with that, we have proposed this STM32 based microcontroller energy monitoring and home automation system, which will provide us accurate details of real-time data and also the controlling of the connected appliances. These are some of the references that we have used. Thank you.
Thank you for your presentation. Just one question. Such type of devices are available in the market. Then how you will, what is your uniqueness of your device?
Ma'am, we were mainly looking for such devices which are available in this price range. They are giving us only the option to, control the devices remotely. And this energy consumption data and plotting graphs and giving the analysis about that we are trying to add as a novelty over here. And through TFT screen, we can control it, which also we can consider it as one of the security concerns that, if we have to send data to the cloud and everything, then that has to be secure. But if it remains within the house, then it is secure.
Okay. Are you, again, it will be a mobile application?
No, we haven't developed any mobile application.
Okay. And how will you monitor all these things?
Currently, we will be doing all this locally. So for the future scope, once we get to further better things, we can plan for remote operability.
Okay. Thank you.
Thank you.
Thank you so much, sir, for your presentation. Thank you, ma'am. That brings us to the end of our presentations. I sincerely thank our authors for their excellent presentation and contributions, and all participants for being a part of this international conference. I hope this session was informative enough for all of you. We, on behalf of the whole team, thank you for the support during this 8th version and the previous 7 versions of the conference. We'll be happy to have you in the next session as well, in the 9th version in 2025. All the presenters would be getting their digital certificates through their email within 2 working days. Further, all the papers have already been forwarded to the Spranger. The publication will be live within 6 months. Kindly cooperate with the same with the team of SMARTCOM 2024. I also thank our session chair, Dr. Akhilesh Kumar Sharma, for chairing the session, and Chaya ma'am for chairing the session.
Thank you, Aarti.
Thank you, ma'am. Yes. Just give me.
Ma'am,
Yes, please.
ma'am, can we get a recording of this session?
Yes, it would be visible in YouTube.
Okay, ma'am. Thank you.
Yeah. And I would like to thank Chaya ma'am for chairing the session as well. A token of appreciation, to the chair on behalf of Team SMARTCOM and Global Research Foundation and partners. Thank you, ma'am. Thank you, sir, for your valuable presence.
Thank you, Aarti. And thank you all the presenter. Those are presented very nice presentation, and topic chosen was very recent topics were there. So I really thanks for calling me as a session chair for this. Thank you. Thank you, Aarti, for nice coordination.
Thank you, ma'am. Thank you for your valuable presence and your kind remarks. So I would kindly request you all to switch on your camera for a quick snapshot of the virtual conference. Everyone, please switch on your camera. I request everyone to please do the same.
And save this, send these photos also. Snap this.
Sure, ma'am. Sure. I'll share. We'll share it with everyone. Thank you so much. Stay safe. Take care. Thank you all.
Thank you.
Thank you so much.
Thank you.